All right, so this document is going to help us remember some of the properties of exponents and then develop a new relationship. So two things to remember. Exponentiation is repeated multiplication or division of 1 by the base. Okay, so for instance, x cubed actually means 1 times x times x times x. It's not really x times itself 3 times because that would be 4 x's. So we're really doing 1, which is the multiplicative identity, right? When you multiply it by something, it doesn't change it. 1 times 3 is still 3. So x cubed really means multiply 1 by x 3 times. Y to the negative 4th means divide 1 by y 4 times. So a negative exponent just means divide instead of multiply 1. So it's helpful here because the 1 usually doesn't show up here. We usually just write x times x times x and that's fine. But when we're dividing, we need something to hold the place in the top of the numerator. And so it makes sense to say it's 1 divided by y times y times y times y. And a reminder here that if you're dividing by y, that's the same thing as multiplying by reciprocal. That's how division is defined. Division is multiplication by reciprocal. And so it's y to the negative 4 is the same as 1 times 1 over y times 1 over y times 1 over y times 1 over y. So sometimes it's easier to divide, sometimes it's easier to multiply by reciprocal. We want to be flexible doing both. So it says write out the following as repeated multiplication or division of 1 by the base, then simplify. No properties allowed, just repeated multiplication or division. We're using the fact that division is multiplication by reciprocal. So for the fourth, well, that should be 1 times 4 times 4 times 4 times 4. And that, of course, is 1 times 16, which is 256. 2 to the negative 3 is 1 divided by 2 times 2 times 2, which is 1/8. I could also write 2 to the negative 3 as 1 times 1/2 times 1/2 times 1/2, because dividing by 2 is the same as multiplying by 1/2, and that's still 1/8. 3 to the negative 2 means divide 1 by 3 twice, so that's 1 divided by 3 times 3, and 2 to the 5th is times 2 times 2 times 2 times 2 times 2. So we're multiplying 1 by 2 5 times and dividing it by 3 2 times. 2 to the 5th is 32, so that's going to be 32 divided by 9. 2/3 to the negative 2 means one of two things. It either means take 1 and divide by 2/3 twice, right? Because the negative exponent means divide. And we can do it that way, that's fine. That means it's going to be 1 divided by 2/3 times 2/3 is 4/9. But remember, division is multiplication by reciprocal. So 1 divided by 4/9 is the same as 9/4. If instead of dividing by 2/3, I wanted to multiply by reciprocal, I could just do 1 times 3/2 times 3/2, right? Dividing by 2/3 twice, same as multiplying by 3/2 twice. So 2/3 to the negative 2 could either be 1 divided by 2/3 times 2/3 or 1 times 3/2 times 3/2. And that's going to get you 9/4 either way. So it sort of depends on which one makes more sense to you. Okay, so that's just sort of reminding ourselves what exponents do. We know pretty well what we have a good sense for positive exponents, but negative exponents can be a bit confusing at times. Okay, fundamental properties of exponents. We'll just remember that this is a to the m plus n. If you multiply m times and n times, then you're multiplying m plus n times. We know that a to the 0 means multiply 1 by a no times, so it's just 1. A to the negative n means 1 divided by a to the n, or alternatively 1 times 1 over a to the nth power. That's the same thing, again, multiplying by reciprocal or dividing. 1 over a to the negative n, well, that would be 1 over a to the n, using this rule here, right? Because the denominator is now 1 over a to the n. But that's multiplication by reciprocal, If I divide by this, it's the same as multiplying by a to the n, so that's just a to the n. Okay, so the rule is negative exponent becomes positive in the denominator. If it's already in the denominator, it becomes positive in the numerator. We know that if we have ab multiplied m times, that's just a multiplied m times and b multiplied m times. Same thing with a fraction. This is a to the m divided by b to the m. And we already looked at what happens when you take a fraction to a negative power. It just becomes the reciprocal to the positive power, right? Because division is multiplication by reciprocal. So those are the fundamental properties of exponents. Okay, turning the page. We can simplify these to write with all positive exponents. So I'm going to basically change these so all my exponents are positive. So the 6 doesn't move anywhere because it doesn't have an exponent, or if it does, it's 1. I'm going to leave the y, I'm going to leave the z to the 4th, but the x to the negative 2 I'm going to move down into the denominator to make it division. So it's going to be 2x squared, so the x to the negative 2 came down. The z to the negative 3 I'm going to move up to the top and make z cubed. This x to the negative 2 I'm going to move up and make x squared. And then this y to the 4th stays. So again, if I want to make the exponents positive, instead of multiplication, I make them division, because we know that multiplication by reciprocal is division. Now I can see what I can divide. Well, there's an x squared and an x squared. I can divide those. I've got a y over a y to the 4th. I've got a 6 over 2, that's a 3. Y over y to the 4th leaves y cubed in the denominator, and z to the 4th times z cubed is z to the 7th. So I've got 3z to the 7th divided by y cubed, and that's with positive exponents. Okay, here one choice would be to distribute everything. So if I distribute this exponent, in a sense, it applies to everything. So I get 3 to the negative 1, a to the negative 2, b to the negative 1, c squared. Then I should have 4 squared, a squared, c squared. So I'm just making sure to use that property there. Now 3 to the negative 1 is the same as 1 divided by 3, so that's 1/3. Then the a squared is going to come down to the denominator, a b is going to come down to the denominator, and everything else stays. So 4 squared is 16. And then I have an a squared left, and I've got a c to the 4th. I can divide the a squareds if I want, and that should leave me with 16c to the 4th divided by 3b. Other ways to do it, but that's just the way I chose to do it. This one, I know that a squared cubed, I multiply these exponents, so that should be a to the 6th. I'm wondering if there should be more properties on this side. Oh yeah, I skipped a couple. Why did I skip these ones? A to the m to the n, that's a to the m times n, and a to the m divided by a to the n is a to the m minus n. I'm not sure why I skipped those. Okay, so I multiply these exponents. So 2 times 3 is 6, times negative 1 is negative 6. So this is a to the negative 6 times a to the 6. Now I add these exponents and get a to the 0, but a to the 0, of course, is 1, because it means multiply 1 by a no times. This one is just a bunch of numbers. So 1/3 to the negative 2 I know is 3 squared. That's times 4 squared divided by 4 squared times 3. I can divide the 4 squareds. And 3 squared over 3 is just 9 over 3, which is 3. So those would be my final answers there. So that's sort of a review of some of the things we want to know about exponents. So now let's move on into something new. So defining roots. So if b squared equals x, then b is a square root of x. We know that. Example, 4 squared equals 16, so 4 is a square root of of 16. If b cubed equals x, then we say b is a cube root of x. Example, 2 cubed equals 8. So 2 is a cube root of 8. If b to the fourth equals x, then b is a fourth root of x. Example, 3 to the fourth equals 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So 3 is a fourth root of 81. Finally, in general, if b to the n equals x, then b is an nth root of x. Okay, so we've got a square root, a third root, a fourth root, an nth root, and they all work in a similar way. So 10, is the cube root of a negative number real? Why or why not? Well, I encourage you to think about that. But the answer is yes, it is. Okay, because when you have a negative 2 times a negative 2 times a negative 2, you've got 3 negatives. So you can get a negative number for a cubed root. So the cubed root of negative 8 is a real number. It's negative 2. Is the fourth root of a negative number real? Why or why not? The answer to this is no. If you try and find a number that multiplies 4 times to get, say, negative 16, this is not real because you have an even number of numbers, and so there's no way you're going to get a negative if you're multiplying the same thing every time. Okay, so this is just very basic definition of roots. Now let's extend it to something else. So 2 to the 1/2 squared, we know what happens here is that we multiply the exponents. So 1/2 times 2 is 1. So this is 2 to the first, which is just 2. Similarly, 3 to the 1/2 squared is 3 to the 1. And 4 to the 1/2 squared is just 4 to the 1, or 4. So let's recall, if b squared equals x, then b is a square root of x. So what is x to the 1/2? Well, x to the 1/2 squared would just be x, right? X to the 1/2, if we square it, we multiply these exponents and we just get x. But that's basically telling us, since this squared equals x, that's a square root. So x to the 1/2 is another way to write the square root of x. Okay, now we're going to extend that. So 2 to the 1/3 cubed, if I multiply these two, I'm going to get the exponents rather. I'm going to get 2 to the first, which is 2. And 5 to the 1/3 cubed, that's just 5, because the 3 times the 1/3 is just 1. So recall that if something cubed equals x, then that something is a cube root of x. So what is x to the 1/3? Well, x to the 1/3 cubed is x, so this is the cubed root of x. Since x to the 1/3, b in this case, cubed is x. Okay, so x to the 1 over n to the n, well, what is that? That's just x, because you multiply the n times the 1 over n. So recall that if b to the n equals x, then b is an nth root of x. So what is x to the 1 over n? Well, it is the nth root of x. So we now want to be recognizing that a fractional exponent is giving us a root. So 25 to the 1/2, oh, that's the square root of 25, which is 5. 8 to the 1/3, oh, that's the cubed root of 8, which is 2. Negative 64 to the 1/3, that's the cubed root of negative 64, which is negative 4. So these fractional exponents are just roots. going the other way, if we have a square root, we could write this as 36 to the 1/2, which we know is 6. This we know would be negative 125 to the 1/3 power, and that's the cubed root of negative 125, which is negative 5. And this would be negative 16 to the 1/2, which is technically 4i, right? Because this is root 16 root negative 1, and that is 4i. Okay, so that takes care of it. We've got some definitions, the most important of which are probably that x to the 1 over n is equal to the nth root of x. In other words, this is looking for the number that multiplies n times to get x. Great.